energy intake. We counseled on the basis of weight change. It's important to understand that as well. We did not prescribe 25% CR. We did not use 25% CR as the target for the individual. We used their weight as would be expected to be responsive to 25% CR. We also designed the experiment such that there would be a weight loss period of up to 1 year, and what we hoped would be a weight stabilization period of 1 year. This is important to understand that we wanted to assess the effects of CR not only during the initial weight loss period, but also during the weight maintenance period. Because after all, if the cronies are experiencing caloric restriction as a steady state, right, and their weight is not changing, and so it's very important to understand what the biology is during that weight stable period. So the samples of 12 to 24 months, in general, is a weight stable period in CALERIE. So if you want to understand that biology, that's those samples that you want to have access to. Questions? Okay. This is actually what we saw. We have energy intake at the top, and we have weight change at the bottom. So what you see here is that, and this is from the primary paper that was published in JGMS. What you see here is the AL group is fairly stable on energy intake, basically no change in energy intake. There was a very good response in energy intake, 15% reduction during the initial 1 year. And then there was some recidivism, if you will. So there was a fall off up to approximately, I think it was 12% in the second year. So on average, we had a 12%, over the course of the whole period, we had a 12% caloric restriction achieved in this population. The weight loss curves look like what we expect. There's a weight loss up to about 12 months, and then it's not stable, a little bit of increase in the subsequent year, but roughly weight stable during that period. This is the change in body composition that we saw. There's a blackening on the right-hand bar that's missing for the fat mass. But what you see is that the majority, but not all, of the weight loss was fat mass. There's a fat-free mass loss. That's what you expect with any weight loss intervention. It can be anywhere from a third to a quarter to a third in general. You see a fat-free mass loss with weight loss. These is the change in core temperature. You can see that those stars indicate that there's a within group significant change, but not when compared to AL. So very important that we have a control group in this study, as you'll see in some of the outcomes. If you didn't have a control group, you wouldn't make sense of a lot of the observations. This is the change in bone density. These are all published, by the way. I see the references here at the bottom. These are all available on the website. Again, the links to these publications. There was some loss of bone mass with the CR intervention. Again, this might be a conservative adaptation. You know, if the body has less weight, it probably needs less bone mass to support that weight. It's not surprising. We see this, by the way, in spaceflight, of course. They're one of the major consequences of long-term microgravity exposure is bone loss, and that's because the skeleton is not carrying weight, and there's no inducement to maintain that bone mass. And we saw this here in CALERIE. Those are reflected in changes in some of the bone synthesis markers. So we're getting to some of the molecular data immediately. So, and these were primarily assessed, by the way, in urine, not in blood. So this is the importance of the urine samples. There are a lot of metabolites and other analytes that can be concentrated in the urine, and the urine can be more sensitive. So we're very conscious of collecting the urines as part of the CALERIE study. Those are available for analysis as well. Metabolic adaptation. So here is the bar graph at the top. You see that in the early phase, the first 12-month phase, there appeared to be a metabolic adaptation within group analysis, but when compared to AL, this is change in RMR, by the way. So there's a change in RMR detected at 12 months and not at 24 months within group for the intervention group, not for the AL group. But when compared, so what you see at the bottom is a regression line is drawn for the relationship between body mass and RMR, okay, across the study. And then what you do is you could draw the curve, or the change in the curve, or the curve after the intervention. And those are shown by the dots as well as the dotted line. And so the difference between those lines, the vertical drop, the difference between those lines is the metabolic adaptation. And although we saw a metabolic adaptation of 50 kilocalories per day in RMR, which is, by the way, what we determined ad hoc was our sensitivity is about 50. Okay, so the technical variation of the test is about 50 kilocalories per day. This is just on the borderline, the sensitivity of the error of the test, the technical and biological error. And there was a small drop in the AL group, so it wasn't actually clinically significant. This is at 12 months. When you look at 24 months, there's clearly no significant difference between the groups. So we concluded that although we might have seen a small metabolic adaptation early, we saw no metabolic adaptation over the course of certainly in the weight maintenance phase. And we believe this is due to a difference in energy expenditure, right? The difference we did see. There was an adaptation in the intervention group such that they decreased their physical activity enough to accommodate that difference or account for that difference. Yes, Roz.
I was just going to say that there's a known adaptation to weight loss that happens where bodies that for people who are trying to lose weight become more metabolically efficient. It's a bit cruel, really, but the more you try to lose weight, the more your body fights against you. And there's some really nice work done by people like Dale Schuller and Klaus Westerter in the Netherlands, showing that metabolic adaptation as a function of weight loss. It usually resolves then when people weight stabilize. So I think the adaptation, I just be very careful about what we're looking at, and the fact that the context is not equivalent moving from 0 to 6 months, 6 to 12. It's shifting as we go, and that the 12 to 24 period it's a different biological setting than
Yes.
0 to 6.
Yeah. And it's important to understand when you're analyzing these samples or data, are you looking at 0 to 24? Are you looking at 0 to 12, 12 to 24? And of course, if you do a change to 0 to 12 and then 12 to 24, those are not independent observations, right? You've got that middle point that's tying them together. I defer to Carl on the cautionary note on that analytic approach. So this is the change in physical activity. We did see that. So these are the cardiometabolic outcomes. I just wanted to spend a minute on that. We found these to be highly significant. Remember, these are individuals that came in with a normal blood pressure, 110/70. So even in these individuals, we saw a rapid and sustained improvement in systolic and diastolic blood pressure. So those stars are to indicate levels of significance. We saw a sustained and significant improvement in LDL cholesterol in individuals already with a good LDL cholesterol. We saw an improvement in the area under the curve glucose in individuals that already, OGTT, and individuals that already had good glucose control. Remember, the fasting blood glucoses were 80. And metabolic syndrome score. So we formed metabolic syndrome is a conglomeration of 5 cardiometabolic risk factors, commonly thought to be at risk for diabetes, and we saw a sustained and persistent improvement in metabolic syndrome. And then I bow to Asai again. This is a very elegant way of presenting these data, where the green bars indicate a significant change within group, I think, and the yellow bars between groups, and the yellow bars are the within group changes. Oh, I'm sorry, the 0.01 and the 0.05 level. Thank you. Behavioral variables. So this is area Corby is an expert in. I won't go into all the details about how the analysis was done and the publications, but these are the basic observations. We found no eating disorders, depression, or other psychological